to H3C Tech Talk. I'm Rina from the Marketing and Communication Department. Today, I'm gonna be the host here. For those who are not so familiar with us, H3C is one of the leaders in digital and AI solutions. With a strategy of Synergy Plus, we integrate cloud, networking, security, and all the related AI-driven innovations to empower enterprises worldwide on their digital transformation journey. This is the first session of our Tech Talk series, and we are so excited to share the first topic here, from high speed to true intelligence, the AI-driven Wi-Fi 7 for enterprise. This session will cover how Wi-Fi 7 is evolving beyond high speed, and also how AI is enabling the true intelligence for enterprise. Now, let me introduce our speaker today, Hızdan Zhang, the product manager of our international business group. Hızdan, thank you for being here. Please take it away.
Okay, thanks, Rina. Hello everybody. I'm Hızdan Zhang, the product manager for H3C International Business Group. A very warm welcome and thank you all for joining this Tech Talk. I'm truly excited to dive into what's next in wireless. So today we're exploring Wi-Fi 7 and more importantly, how to unlock its full potential. So we will make the essential transition from talking about the raw speed to delivering real intelligence and detail how AI transforms Wi-Fi 7 into the smart, efficient network your enterprise needs. So let's get started. Well, let's begin by setting the context. If we look back at Wi-Fi 5, it was a significant step forward with its 80 MHz channel width and 4x4 downlink MU-MIMO. Then Wi-Fi 6 arrived, doubling the channel bandwidth to 160 MHz and introducing more efficient 8x8 uplink, downlink MU-MIMO. These were solid foundations, but as digital demands continue to explode, the need for even greater speed, capacity, and efficiency has never been greater. So this brings us to today's focus, that is Wi-Fi 7. This new standard represents a massive leap forward. We're not talking about 320 MHz channel width. So once again, doubling the capacity of Wi-Fi 6, and alongside further enhancement to multi-user technologies. This is not just an incremental upgrade, it's a fundamental transformation in wireless capability. At H3C, our leadership in this evolution is not accident. It's the result of a long-term commitment. So in fact, our journey to the forefront began back in 2009 when we first ranked #1 in China's enterprise WLAN market. So for the following 16 years, we have consistently maintained that leadership position. And this deep expertise allowed us to launch the industry's first enterprise-level Wi-Fi 7 product, the WA7638 in 2022. That wasn't just a product launch. It was a clear statement of our vision and technical capability. And our commitment doesn't stop with Wi-Fi 7. So looking ahead to 2025, H3C is positioned as a core participant in the IEEE 802.11 task group, actively shaping the future Wi-Fi 8 standard. And we have already contributed over 40 technical proposals, driving crucial reliability breakthroughs for the next generation of wireless. And if we trace this innovation timeline, you can see our legacy of firsts, from introducing early Wi-Fi 5 global access points like the 4630 in 2013 to pioneering triple band Wi-Fi 6 technology with the WA4330 in 2019. So from Wi-Fi 5 to Wi-Fi 8 and beyond, H3C isn't just following trends, we're setting them. So what does this leap mean in practice? Well, Wi-Fi 7 is a game changer, delivering speeds 4.8 times faster than Wi-Fi 6 and ultra low latency under 3 milliseconds. But how? Well, the first reason is because the new 6 GHz band increases channel capacity. And the second reason may be the bandwidth doubles to 320 megahertz and more than doubling peak rates. And thirdly, the 4096 QAM modulation boosts data encoding for a 20% gain. And at last, technologies like MLO improve spectrum efficiency. So you can think of it like a highway. So if Wi-Fi 6 160 megahertz highway carries N vehicles, that Wi-Fi 7's 320 megahertz highway can carry 2N, that enabling higher speeds, more users, and less congestion. This is a fundamental upgrade. And now you may wonder, what is the foundation behind such continuous innovation in Wi-Fi 7? Well, this slide summarizes our journey and leadership. And for 22 years since 2003, H3C has been committed to sustained R&D investment and focusing on delivering cutting-edge wireless solutions that meet the real-world needs of various industries. And this long-term commitment has yielded remarkable results. Like H3C has maintained the #1 position in China's WLAN market share for an impressive 16 consecutive years, a testament to our deep understanding and leadership in the region, backed by a strong and growing international presence. And moreover, our leadership is consistently recognized by top industry analysts. Well, as you can see, the IDC data confirms that we've been #1 for 16 years from 2009 through 2024. And globally, we are proud to be positioned as a leader in the prestigious 2025 Gartner Magic Quadrant for Enterprise LAN and WLAN infrastructure. Well, this independent recognition validates our technology and strategy. And this market leadership isn't accidental, like I just mentioned. It's built by actively driving industry transformations. For instance, we were one of the earliest pioneers to bring high-density wireless to the education sector, which remains one of our largest and most successful markets today. So in short, partnering with H3C means partnering with a proven, stable innovator. Well, this legacy brings us to what truly sets us apart. While others focus on hardware, but our philosophy is that a superior network is 30% product and 70% optimization. Well, hardware is the foundation, but the true brains lie in our software and AI. And all our innovations aim for one goal, that is a superior, seamless user experience. It's about intelligent performance that goes far beyond the hardware. But how does this philosophy solve real problems? Well, you can consider these frustrations in our life, like policies that work at HQ fail at branch offices. Like the Wi-Fi is slow, but you have no visibility into why. And maybe you have encountered some conditions like video calls freeze during critical meetings, and some security is a blunt allow or deny tool. Well, these are the four major roadblocks. That is fragmented management, lagging O&M, a poor experience, and weak security. The old mindset of as long as it's connected is obsolete. We need networks that evolve from being connected to being business aware. And beyond connectivity, that means service intelligent enterprise development. So in the past, we built networks just to achieve connectivity, but now we need a network to understand the business and manage well and defend against threats. And how do we achieve this? We can look at the four major trends. The first trend is the business assurance trend. That means intelligent resources allocation. The focus is no longer on simply allocating resources equally. Instead, we use AI to recognize the characteristics of every application. For example, giving the Tencent meeting priority while appropriately throttling the FTP downloads. This truly achieves service on demand. And the second trend will be the operations and maintenance. We call it O&M trend. That means AI-driven automation. Yet we aggregate all network data into the cloud and using AI to analyze issues, make automatic decisions, and execute closed-the-loop actions. This realizes an automated O&M process of perception, decision, and execution. And the third trend will be the security trend. That means continuous verification and zero trust. Security is moving beyond a one-time authentication and approval, like the zero trust model. It continuously validates whether terminal behavior is normal and dynamically adjusts permissions. And the fourth trend is the management trend. That means cloud native unified management. Well, the goal is to use a single cloud platform to uniformly manage all devices and all branch offices and all scenarios. Furthermore, AI can help us with policies orchestration. And based on the recognition and judgment of these four trends, H3C has proposed the cloud plus 4I technology system. And so, what exactly is cloud and 4I? Well, simply put, it means the brain is in the cloud and the hands and feet are at the edge. Well, the brain in the cloud, that means the CloudNet platform. First, we have the CloudNet management platform. It's responsible for managing the entire network and collecting all the network data, such as network health metrics, logs, alerts, and user behavior, etc. This data is then put through AI modeling and analysis to generate optimal strategies. For instance, the fine-tuning radio frequencies, steering roaming devices, or isolating risky terminals. And about the 4I, we call it the hands and feet at the edge. Next are the devices like AC and AP that possess the 4I capabilities. They are responsible for the rapid execution and the response to the policies pushed down by the cloud management platform. So the 4I capabilities include, firstly, the iRadio. That means optimization of wireless air interface resources. And second is iStation. That means management of terminal access and roaming. And we also have iEdge, that is edge processing for application identification and acceleration. And also we have iHeal, that means proactive issue discovery and self-healing. So to summarize, the cloud is responsible for thinking, learning patterns, predicting trends, and coordinating the overall strategy. And the edge is responsible for doing the work, that is real-time response and rapid processing. And this is a cloud edge collaboration. So in other words, cloud intelligent aggregation, edge intelligent empowerment. These two work together closely to give the W-line network a closed loop capability of perceive, analyze, decide, execute, truly transforming it into intelligent productivity. And this achieves the three main goals: smoother networking experience, smarter O&M, and more precise security. And now let's look at how this system actually works in real world scenarios. Well, you can imagine these scenarios like a doctor is checking a patient's chart on a tablet, then suddenly loses the network connection walking down the hallway. And maybe in the factory, an AGV, that is automated guided vehicle in a factory, stalls because it failed to switch to a new access point. And maybe a subway passenger watching a video experiences a stutter or pause every time the train pulls into a station. Well, these are all classic roaming issues. The traditional approach is a one-size-fits-all solution. All devices use the exact same roaming parameters, but the reality is different phones, operating systems, and user behaviors mean completely different roaming needs. So our solution is AI coordinated roaming, achieving one policy per device and per network, leading to personalized roaming. And how is this done? First, we do the cloud modeling. The cloud can collect behavioral data and air interface characteristics from thousands of terminals to train an AI model and establishing a roaming profile for each device type. And we also do the edge fine-tuning. When a terminal connects, the local AP makes precise real-time adjustments based on the current situation, such as proactively steering the device to switch to a better AP sooner. And it's just like an navigation app, the cloud tells you this road is usually congested, and your local device then combines that with real-time traffic data to give you the optimal route. So the result is roaming becomes more timely, reducing stickiness, and the real-world tests show a throughput increase of 8% to 10% during the roam process. Mobile services truly achieve the seamless or unperceived handover. And let's look at another challenge that is high density and concurrent multi-service use. Well, take a university dormitory, for example. Hundreds of students are online simultaneously, and some are gaming, some are attending online classes, and others are downloading movies. If the network lacks intelligent scheduling, a bandwidth grab phenomena occurs that will cause gaming lag spikes and videos constantly buffer. So our solution is stereoscopic scheduling. So how it works in cloud edge layering, specifically, how is this implemented? First, we do the cloud learning and prediction. The cloud continuously accumulates a service feature library. It identifies, for example, that Tencent Meeting is low latency sensitive, while an FTP download can be queued. And it then regularly pushes the optimized scheduling algorithm to the edge device. And we also do the edge real-time execution. At the local site, the edge layer, the AP identifies services through the service profiling and applies tags. It currently supports over 1,000 service types and allows for custom definitions. And it uses these tags for intelligent queue management. And based on the terminal capabilities and the current air interface conditions, it selects the appropriate transmission method, such as Wi-Fi 7's MLO. We call it the multi-link operation aggregation, or OFDMA, shared transmission, achieving a one policy per device scheduling. So what are the benefits? We can tell from the real world data. Well, firstly, the single AP support 100 Mbps high-speed downloads plus 40 concurrent audio and video streams, and it can smoothly carry 130 simultaneous high-definition video streams without stuttering. And the concurrent capacity is increased by 10% compared to traditional solutions. Well, this highlights the advantage of cloud edge collaboration. So the cloud is responsible for long-term learning and strategy updates, while the edge handles real-time scheduling and precise execution. This is true 1,000 phases, 1,000 policies scheduling. It's not equal distribution, it's allocation on demand. Well, the third key to a smooth experience is radio resources management. We call it RRM. What was the traditional approach? It was a post-factum remedy, waiting for interference to appear before making adjustments. And furthermore, it only looked at historical data and couldn't predict future trends. But AI RRM is fundamentally different. It uses AI in the cloud to predict future trends and conduct simulations. Specifically, it involves firstly collecting historical data plus current business load. And also it involves training a model to predict tomorrow's traffic trends for various time slots and simulating multiple algorithms in the cloud to select an optimal solution and judging which result is superior by considering both co-channel interference metrics and channel load, making the evaluation more reasonable, and only issuing the command for execution if the new plan is proven to be better than the current live network configuration. So to summarize, the cloud is responsible for computing, like predicting trends and comparing simulations, and the edge is responsible for adjusting, receiving instructions, and making real-time changes to parameters like channels and power. So what's the effect? Well, actual test data from 8 APs using 6 channels shows that AI RRM compared to traditional RRM, it reduced total interference from 94 down to 51. So that is almost 46% drop. And it also reduced the strongest interference from 65 down to 26. That is a massive 60% drop. So AI RRM is no longer a passive response. It's about proactive prevention and optimization, ensuring the wireless environment always operates in its best state. And also in the past, troubleshooting relied entirely on the experience and patience of the engineers. A single issue could take hours or even days to resolve, and often complicated by transient temporary fluctuations. Now we allow AI to act as the network doctor. So the first part is the edge. Edge is the body check. We deployed the Doctor AP, which is unlike a standard probe. It simulates the user behavior by proactively initiating operations like WeChat, voice or video calls, and web access. It reports the test results along with the device's network status information to the cloud. And the second part is the cloud. It acts as the diagnostic brain, utilizing algorithms like neural networks and deep reinforcement learning. The cloud platform integrates vast amounts of WLAN data and H3C's rich maintenance experience library to train this model. And this intelligence is offered through 3 major tools, that is terminal smart diagnosis, network smart diagnosis, and network health check. And the current results in practice are very, significant. About the terminal smart diagnosis, the issues that previously required hours of investigation can now be localized in just minutes. And for network smart diagnosis, it provides over 60 specialized analysis and network issue localizations, filtering out 99% of noise interference. And about network health check, it generates regular health reports, allowing for proactive prevention rather than reactive fixing. So to summarize this, the cloud is the diagnostic brain, analyzing data, matching cases, and outputting conclusions. And the edge is the physical examiner, truly simulating business flows and collecting firsthand experience data. It's just like a hospital visit for a physical exam. So local instruments collect the data, and the doctor makes a comprehensive judgment backstage. The ultimate result, even novices can act like experts, and O&M no longer relies on eating by experience. So as you can see, the cloud and 4i architecture is a proven framework and that delivers intelligent solutions for any business scenario. So to close, we can take a final quick look at H3C's Wi-Fi 7 full scenario upgrade solution. We are ready to reimagine your high-end smart campus networks with ultra-high throughput plus full scenario intelligence. So we include some key highlights. Firstly, the massive bandwidth and speed. We have Wi-Fi 7 supporting the 6 GHz band and 320 MHz ultra-wide bandwidth, and combined with 4096 QNM technology, access bandwidth is boosted by 120% and providing up to 46 Gbps of throughput. While this ensures that even tens of thousands of users can be online simultaneously without stuttering. And number 2 is the high-speed backhaul. All products in the full scenario solution support 2.5G, 5G, 10G backhaul, enabling core data to be transferred in seconds. And thirdly, smart power management. We feature full scenario multi-rate PoE, that is power over Ethernet, intelligent power supply, which allocates power on demand, making deployment and O&M simpler and more worry-free. And at last, the zero latency backbone. We have the 25G, 100G backbone network architecture. It can act as the compass information artery, carrying massive data volume with zero latency flow. Well, from wireless access to backbone transmission, this comprehensive solution creates a stable, high-efficiency network of the future for scenarios like technology parks, commercial complexes, and more. So thank you for your time and attention. H3C is committed to pushing the boundaries of wireless intelligence, and please follow H3C for more innovations. Thank you.
Thank you, Celestine, for the great insights. And thank you all for joining our first H3C Tech Talk. We hope you found it valuable, and we look forward to seeing you in the next episode. Goodbye and have a wonderful day.